Let's get straight on and look at the basic electricity definitions and calculations, as well as some examples. At the end will be a couple of combinations of equations that may make power calculations easier for you. Don't worry too much about what charge is. You'll be scratching your head for days. It's just a physical property of matter, like mass. But charge can be positive or negative. Accept that and move on. Charge has the symbol Q and is measured in coulombs. Current has the symbol I and is measured in amps or amperes. Why Q and I? Well, blame the French. Current is the rate of flow of charge or the charge flowing per second. Look at this circuit. We have a current of 3 amps flowing from the cell to the lamp. This means that 3 coulombs of charge are flowing every second. In equation form, it looks like this. Current equals charge over time, or I is Q over T. Let's use this equation in a couple of examples. Here, 10 coulombs are flowing every 5 seconds. What is the current? Well, current equals charge over time, so current equals 10 over 5, which equals 2 amps. In this circuit, how much charge can a current of 3 amps supply in 5 seconds? Charge equals current times time, and so charge equals 3 times 5, which equals 15 coulombs. The equation can be written in 3 ways, and here is also the triangle if you find that useful. Voltage has the symbol V and is measured in volts. Voltage is the change in energy per unit of charge, or the work done per unit of charge, however you want to say it. It can sometimes be called potential difference. Remember that charge has the symbol Q and is measured in coulombs. Look at this circuit. We have a cell supplying 3 volts. This means that for every coulomb of charge moving through the cell, the charge gains 3 joules of energy. The lamp also has a potential difference of 3 volts across it. That means it takes 3 joules of energy from every 3 coulombs of charge that passes through it. In equation form, it looks like this. Voltage equals energy over charge, or V equals E over Q. Let's use this equation in a couple of examples. Here a battery provides 12 joules of energy to 3 coulombs of charge. What is the voltage? Well, voltage equals energy over charge, which is 12 over 3, which is 4 volts. In this circuit, a lamp has a voltage of 6 volts dropped across it. How much energy is given to the lamp by 5 coulombs of charge? Well, energy equals voltage times charge, which is 6 times 5, which is 30 joules. The equation can be written in 3 ways, and here is also the triangle, if you find that useful. Next comes resistance and Ohm's law. Ohm's law tells us that for an ohmic conductor, the current through it is proportional to the potential difference across it, provided the temperature remains constant. Proportional means that if we plot a graph of current against potential difference, we get a straight line. Examples of an ohmic conductor are a resistor or a wire. In equation form, resistance equals potential difference or voltage over current. Using the correct symbols, R equals V over I. We can of course rearrange this so that V equals I times R, or I is V over R. Let's look at some examples. We have a 32 ohm resistor with a potential difference of 8 volts across it. What is the current flowing through it? Well, I is V over R, so 8 volts divided by 32 ohms equals 0.25 amps. This is a 12 volt lamp with a current of 0.5 amps flowing through it. What is its resistance? Well, R is V over I, so 12 volts over 0.5 amps gives us 24 ohms. Here we have a 1200 ohm resistor with 3 amps flowing through it. What voltage makes this happen? Well, V is I times R, so the voltage is 3 amps times 1200 ohms, which is 3600 volts. So here are the 3 forms of the equation and the triangle, if you find that useful. Power is the rate that energy can be changed. It has the symbol P and is measured in watts. If we increase the current, we increase the power. When we increase the voltage, we increase the power. So power is current times voltage. Remember, current has the symbol I and is measured in amps. Voltage has the symbol V and is measured in volts. Therefore, P equals IV. My lamp runs off 12 volts and is supplied with a current of 0.6 amps. What is its power? Well, power is current times voltage, which equals 0.6 times 12, which equals 7.2 watts. I'm blind. If you look on the bottom of most appliances, you'll find a power rating on a sticker. This one is 2,750 watts. This is my wife's kettle. In the UK, our main supply is 230 volts, which is similar to the rest of Europe. In the US, it's around 110 to 120 volts. So to work out the current, we do current equals power divided by voltage, which equals 2750 watts divided by 230 volts, which is about 12 amp. Funny enough, when I look inside the plug, you'll see there's a 13 amp fuse, which is just about right for this appliance. Here is the equation in its three forms, along with the triangle if you find that useful. I promised you two bonus equations at the end that you might find useful. If we combine the power equation and the resistance equation, we find that we get P is V squared over R, or P is I squared over R. Using one of these may save you from using two different equations in the same answer. Good luck with your calculations.